Okay, algebra students, so today we're going to be working with radicals. So we'll go back and review all of our radicals. And in the past, we worked on simplifying numbers under a radical sign. And remember, your radical sign is this. And so we did little factor trees, and we circled any pairs. And we boxed the loners. Okay, and so then what we did was the name of the pair is what came outside. So just the representative. So notice there are two x's in here, but only one x came out because the name of that pair is the x pair. Okay, and so that's where that outside x came from. And then the loner had to stay home, if you remember. And it's exactly as is. And if you have multiples, you would multiply them together. Okay? So let's take a look at some examples. Our very first example, and you'll write these as I write them. We're looking at the square root of underneath 5x to the fourth. And make sure that you're showing that radical sign going all the way across. Otherwise, it doesn't mean the same thing. And so we can do this the same way. We can write out our factor trees. 5 is prime, so it's already, I know it's a loner. And then x to the fourth, we can do 4. Or if you recognize you're going to have two pairs in there, you could be a little bit tricky. But I'll just do 4 x's. And that's what x to the fourth really means. It's x times x times x times x. And so we've got this pair of x's and this pair of x's. Okay, so the first pair comes out, and then the second pair comes out, and then the 5 stays home. Remember, it's just that this name is x, and this name is x. Well, we're multiplying, so x times x is going to be x squared root 5. Okay, so then in our second example, it's very, very similar. So go ahead and pause this video, try it using this first example, compare your answers to mine. Okay, so my 3 comes out, and just like 5, 3 is prime, so that I know that it's going to be a loner. And then x squared is x times x. There's my pair. So my x comes out, my 3 stays home, and there's nothing left to do on this one. Okay, now we'll get a little bit more complicated, but we're doing the same type of problem. Okay, so on this one, the only difference is we have a little bit more happening in the problem. Okay, so with my 12, I'll work on that first. I've got 3 times 4, and then I know 4 is 2 times 2. So just on the 12, I know I'm going to have the 2 come out and the 3 stay home. So I'm going to separate this into 3 parts to my problem. Okay, then I'll look at x to the fourth, and if you recognize it from the last problem and you know you're going to bring x squared out, that's great. You could pair it into x squared and x squared, and if you recognize that that's a pair, by all means go for it. Otherwise, you'll go into 4 x's, and you'll bring that out like the last one. But I'm going to do that so we can practice. Okay, and then last, we're looking at y squared. That's just like problem number 2, where you have just 2 values, and those are both a pair. So then when we rewrite our final answer, everything that's circled comes outside. So 2 times x squared times y. Each of those were paired, so they get to come out of the radical, and then the 3 has to stay in. Now, we can't simplify this at all when we show that multiplication, so we're actually done with this problem. Okay, our next one is very similar. So just like on number 2, because number 2 is similar to 1, I asked you to pause the video, try it on your own. So do the same thing here. Okay, so pause, work through the problem. Once you're done, unpause and see how you did. All right, welcome back. So what I'll do here is I'm going to separate 18 into 9 times 2, and 9 is a perfect square, so my 3's will come out and my 2 will stay in. X cubed, we've got x, x, and x, so 2 of those pair up and will come out, and 1 will be left over to stay in. And then y to the 4th, we've seen this before with x to the 4th, so I'm going to pair up my y squared and y squared. And again, if you didn't recognize that and you went all the way to 4 of them, you would do the same thing that you did on number 1. And so from here, the 3 comes out, the x comes out, and the y squared comes out. But inside we're going to keep a 2 and an x. Okay, from what we've boxed. All right, so that's if we're simplifying our radicals with variables. Now we can also get into multiplying radicals. And what this says here is it says that if you're multiplying, you can separate out the 2 radicals, or you could work backwards. If you have 2 separate radicals that you're multiplying, you could combine them together. And sometimes it's more helpful to do one versus the other, and it just depends on the problem. Okay, but this rule is important. All right, so our first example that we'll try out, we'll have 2 different radicals we're multiplying. Okay, and there are a couple of approaches that you can take to this problem. You can multiply it all together, or you can look for radical pairs. It's totally up to you. On this one, let's try putting them together first. Okay, and when I put them together, I'm actually, because I know I'm going to have to simplify, and I don't want to have big numbers, even though, 3 times 12 is 36, we might get to larger numbers later, and it's easiest for me to keep my numbers as small as possible. So I'm just going to write it as 3 times 12 underneath one radical instead of separate. So I'm working backwards using this rule. So then what I can do is that when I do my factor tree, I know there's a 3 there, and then 12 is 3 times 4, where 4 is 2 times 2. Now they're all combined in one tree because they're all under one radical. So those 3's get to pair up, those 2's get to pair up. There's no loner because the 4 is actually on one of the branches. Remember, you can only do the leaves. So everything comes out and nothing stays in the radical box or the radical house. So 3 comes out and 2 comes out. Remember that they get multiplied. Okay, our next example is very similar. So again, you're going to try this on your own, but the numbers are a little bit larger. And none of these, you should be using a calculator. So make sure you're not, just using a calculator and then not thinking about it, and you're not learning how to do it. Okay, so once you've written it down, pause the video so you can try it on your own. All right, welcome back. So I'm going to do this one exactly the same way. I'm going to keep them unmultiplied, but I'm going to put the 6 and 54 under one radical. And so then I can do my factor tree. So I'm going to keep 6, even though 6 turns into 3 times 2. The reason I'm keeping it is because I'm looking at 54, and I know that that's 6 times 9. And so I want to get a pair, and I would rather have fewer pairs than more. If you had kept going, you'd have a pair of 2's and a pair of 3's, and that would be fine too. And then the 9, remember, is 3 times 3, and then that's it. So just like over here, we'll pull the 6 out, we'll pull the 3 out, and this time we get 18. So the first thing I'm going to do is I'm going to rewrite this, and I'm just going to rearrange while I do it. So I'm going to say 3 times 6 times y. They don't have to be in the same order because remember, multiplication goes in any order. What you do need to keep in mind is that radical sign does have to cover everything, because if it doesn't, then that means that's come out of the radical house. So now that I have this, I'm going to do my factor tree. So I've got a 3 there, I've got a 3 and 2 for my 6, and then y is just y. So I'll circle the 3 and 3, and then the 2 and y are my loners. They're going to stay in, the 3 will come out. try this one on your own. Pause the video and then come back. Okay, so I did this the same way. I put everything under one radical and I rearranged it so my numbers were grouped together. And then I did my factor trees and all of the pairs got to come out and the loners stayed home. So we're going to multiply these two radicals together. So again, we'll rewrite and reorder. So 3 times 12 times y, all under one radical. You can always lengthen if you need to. Okay, so we've got 3 times 4, which is 2 times 2, and then here, y and y. So we've got a lot of pairs. We've got our 3's here, our y's, and our 2's. There are actually no loners, because remember that 4 is included in the 2's. So everything comes out, nothing is going to stay in the radical house, so we won't have a radical answer. So we'll multiply 3 times 2 times y, remember it's just the representative, so not y squared or anything. So our final answer will be 6y. Pause the video and try it on your own. Use number 9 to help you out. Okay, so just like the last one, I put the radical over everything and reordered. So I had my numbers together and my x's together. I did my factor tree for everything, and then everything paired off. Okay, so hopefully you're pretty comfortable with these at this point, and so we'll make them a little bit trickier. So it's all the same concept, we're just building in the level of difficulty. So we're going to start this problem the same way, where we're going to regroup everything under one radical and rearrange the numbers together and then like variables together. So not like terms, but x's together and then y's together. So we'll have 2 times 8 times x cubed, y to the 4th. Kind of squeeze it in. And then just like before, we'll do our factor pairs. So we've got 2 times 4. And then here, I'm actually not going to branch off all of my x cubes because I can see that I have x cubed and those match. So I'm just going to bring down an x cubed and an x cubed because that can be a pair. And then my y to the 4th, I'm going to remember that that can be y squared. And again, a pair. So over here, we just need to branch off our 4 into 2 and 2. So we've got a pair and a pair. And again, nothing is left out. So everything is going to come outside of the radical. So we've got 2 times 2 times x cubed times y squared, which will be 4x cubed y squared. Okay, so now we've got the square root of 5x times the square root of 20x cubed. And so we'll set this up the same way. Put everything under one big radical house. So we've got 5 times 20 times x cubed. Okay, and I'll work through this one with you just because they are getting a little bit more complicated. So 5 and then 5 times 4, sorry about the handwriting, and then 4 is 2 times 2. So with our numbers, they've all paired off. Great news. And then we've got an x here and then x cubed. So I'm actually going to do all three. X. Okay, well, there's a pair and there's another pair. So again, no loners. So everything comes out. So we'll have 5 times 2 times x. So it's just a representative. So our final answer will be 10x squared. If you're feeling comfortable and confident with these, go ahead and try them as I'm doing them. You can even pause and then wait and see if you did the same thing. Okay, because I'm going to do these the same exact way as everything else. So these are getting really big. I'm just going to write it down here. But I'm going to put everything under one radical. So 10 times 5, just reordering numbers, now my x's, times x squared, times y cubed, all under the radical. All right, so from here, I'm going to do 2 times 5, and then there's a 5. All right, so my 5's pair off, but the 2 is going to have to stay home. And then with my x's, I have x and then xx. Okay, so the x squared will pair, but that x will not. And then with my y's, I've got two y's there. That already pairs off. And then here, 3. So 2 of them will pair, 1 will not. So this time we will have some radicals left over. We haven't had that in a while. So just be very careful. Anything that's circled, the representative comes out. So we've got a 5, an x, a y, and another y that come out. And then what stay home will be the 2, the boxed x, and the boxed y. So we'll just combine everything together. So we end up with 5x y squared times the square root of 2xy, all underneath. Last problem is going to be very similar, so I want you to challenge yourself and try it on your own. Okay, so pause the video, try this out without me, and then you can unpause to watch it. Okay, so I'll do this one with you, just in case you unpaused with a lot of questions. All right, so I'm going to put everything underneath. I'm going to regroup. So 12 times 3, x cubed times x squared, and then y squared times y to the 6th. All right, so 12 is 4 times 3. Bring the 3 down. So we've got a pair of 3's, and then 4 is 2 times 2. So that all paired off. And then over here we've got 3 x's, and then 2 more x's. Okay, so we can pair them. And the order of your pairs doesn't matter. We can separate that one. That's fine. And then our y's, we're going to have 2 y's here. And then from this, you can do it a couple of ways. You can do 6 branches, which I think I'll do, because I think if you are stuck, then you're going to go with all 6 branches. But you might consider, and I'll start like this, that it's y cubed and y cubed. And if you recognize that those are pairs, then you can circle them. If you didn't recognize that, then that's okay. You're going to do all 6. Y, 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 y. Like you're talking to a 2-year-old. But why? But why? Okay, and you'll pair all 3, and that's fine. So we'll pull all of the pairs out. So we get 2 times 3, and then both of these x's. Skip that one, that one's going to stay inside. And then 1, 2, 3, 4 y's. And then go back and make sure that x stays in. Now, if you would recognize 4 y's as the y to the 4th, by all means, write it that way initially. That's fine. So we're going to end up, when we put it all together, with 6x squared y to the 4th times the square root of x.